Okay, well, hope everybody's having a good day. We're halfway through the week. Friday is the end of the 6 weeks. I'm going to start finalizing the grades tomorrow. So if you would like to retake the exam from last week, tomorrow morning is going to be the last day to do that, 8:05 in the morning. Also, if you have any late work, anything outstanding that you need to take care of as well, all of that needs to be taken care of in the morning. If you have any questions, let me know. Now, we are 3 weeks away from what? The IA being due. So we are in the final countdown now. Is there anybody who feels they are completely done with the IA, ready to go? Okay. I still want to encourage you, if you have any questions, please let me know. Just come ask me. I'll do the best I can if I don't know the answer right off. But you still have a little bit of time should you still need to collect data or change the structure or whatever it is that you need to do. Remember to cite all of your sources, all that good stuff. It is going to be recorded as an exam grade. We're turning it in on the 7th of March, that Thursday right before spring break, and then I'm taking the 8th to go ahead and grade all those, get those turned in. Okay, so any questions anybody has right now about their IAs? No? Okay, well, let's go ahead and continue, and we are kind of in the middle of a review unit here. We did relations and functions earlier in the week, and now we are going to go ahead and continue with linear functions. So we'll finish that today, and then we'll go ahead and talk about some quadratics a little more, and then we have some exponentials, and then we can finally start some trig. That's where we have some good fun. Okay, so let me go ahead and get a clean slate here. There were 4 different equations that we were talking about last time. What's one of them? Grayson. Slope-intercept. Okay, so slope-intercept. Okay. That was y equals what? mx plus b. Okay, m was your slope, your rate of change, rise over run. B was your y-intercept. Okay. There was another one. Caroline. Point slope. Okay. So point slope. What was the point slope equation?
Y minus y1 equals m times x.
There you go. Remember, we only plug in for y1, x1, and m. The others what we refer to as generic variables. They have to be there as part of the equation. Sydney, what's the third one? Standard. Okay, so what was standard form? Okay, so ax plus by is equal to c. And this had some specific restrictions that we wanted to go ahead and follow. Not every standardized test, everybody follows them, but it's always good to know them. Let's say, Gabby, what's one of the 3 restrictions or conditions if we're going to say it's true standard form? What can't be negative? A. Okay, so A can't be negative. Coefficient of x has to be positive. That's one. Haley? No decimals, no fractions. And Caitlin, finish it off. She's not sure. Alejandra, can you help me out with that? What's the third condition for standard form? Has to do with factors. Other than 1. Okay. So A, B, and C cannot have any common factors other than 1. And I want to say on Monday, this is where we stopped. We had just introduced this last form. Zoe, you know what I'm talking about? Double intercept form. Okay. Double intercept form. So I'm going to go ahead and write this out in kind of an unusual way. It's going to equal 1. So we have x, we have y. Now, kind of going back to standard form, what ratio would immediately give me the slope, and I don't have to manipulate the equation or anything? Oh, now that's the x-intercept. The opposite of A over B. So the slope was the opposite of A over B. The x-intercept was C over A, 0. And what was the y-intercept? 0, C over B. Okay, so I'm going to go ahead and use those ratios in my double intercept formula. So the x again was c over a, and then c over b. Okay, because if you immediately know what the intercepts are, you can graph the line, and you could rewrite it into any form that you want. I believe, didn't we take double intercept and rewrite it in all the other three? Yeah, I think we finished that up, because yeah, you guys had a lot of fun too. Okay, so let's see here. Yes, I still have that up. We went through all of that. Good, 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 good. All right, so just a real quick example. X over 4/5 plus y over negative 2/3 equals 1. Okay, without manipulating the equation at all, just what we know about the form, I want to go ahead and sketch the graph. So what's the x-intercept? It is 4/5. Okay, so that would be 0.8, so maybe right about here. Okay. What about the y-intercept? What is it? Negative 2/3, yes. You could keep the negative on it, or you could pull it out in front, have it being subtracted. That's perfectly fine. So negative 2/3, probably right about there. And there is the line. There we go. Now, just if you want to review, would anybody like to take this double intercept form and rewrite it into any of the other three forms? Anybody want to do that? Feel confident? Okay. All right. Okay, well, I think this is our last topic, parallel and perpendicular lines. So two non-vertical lines are parallel if and only if they have the same slope. All vertical lines are parallel. Perpendicular, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay, vertical and horizontal lines are always going to be perpendicular to each other. Now, a couple of notations that we use, think way back to geometry. If I'm looking at this, it looks to me like these two lines are going to be parallel, but the first thing you were taught in geometry, or at least I would hope you were taught in geometry, is never trust the diagram. They're never going to be to scale. So if you want to run with the idea that they are parallel, you have to be told they're parallel. Does anybody remember what do we draw on those lines to indicate that they're going to be parallel? Emily? Well, no, the dashes would represent congruence. Okay. The triangles, there we go. So you draw a little darkened triangle. And if you had more than one pair of parallel lines, then you could draw a double set of those triangles there. And then, of course, this one, if two lines are going to be perpendicular, we tend to go ahead and put that little box right there in the middle, because that represents what? 90 degrees. That's exactly what perpendicular refers to. Okay. So let's see here. Let's just put it right into practice. Parallel lines have to have the same slope. Perpendicular lines will have slopes that are opposite. Starts with R. Reciprocal, so you got to change the sign and you have to flip it so that their product is always going to be -1. So here's our example. Yeah, this is the one that we were doing on Monday, so that's the new one. I think I should have another copy right over here. Cindy, do you need another copy of the linear functions? Okay. If not, let me know. There should be one right over there. Okay, so write the equation of the line in slope-intercept form. Okay, so that's y equals mx plus b. That passes through the point -3, 6, and is perpendicular to 3x plus 2y equals 8. Okay, well, we have a point, so as soon as we find the slope, I'm thinking go with point slope, because it's going to be the easiest to write the equation, and we can just go ahead and manipulate it. But we need to find this guy's slope first, but I don't want to take the time to rewrite the function. What was that little shortcut? What was the ratio for finding slope of standard? There you go. So the slope was the opposite of a divided by b. So the opposite of a, -3, divided by b, 2. Now what I want is a perpendicular slope. Does anybody remember the symbol for perpendicular? It was a capital letter, but it was something done to it. Upside down T. There you go. So the perpendicular slope I want, what would that be? 2/3. We take the opposite reciprocal. We flip it, we change the sign. And you always know they're perpendicular because the slope product is -1. Okay, so I got my slope. I got my point here. So like I said, we want to go ahead and start with point slope, and then we'll rewrite it using slope-intercept form. I mean, I guess we could just plug in and solve for b. We'll just run with this idea. What would it look like, point slope, Araya, if I were to plug in my point and 2/3? Y minus 6? 2/3? Plus 3. There we go. Now we just need to do a little bit of manipulating. So y minus 6 equals, what do I get if I distribute? 2/3 x plus 2. Yep, those are going to cancel. And add the 6 over. There we go. Okay, questions? Okay. Good, 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 good. Okay, and then we have this diagram right here. Write the equations for lines L and M. Okay, so here's L, here's M. We want those in slope-intercept form. And it looks like I'm given the third one, 3x minus 2y is equal to 8. Okay. So where should I start? Should we start with L, M? What do you like? There should have been a separate page given when I passed these out. It wasn't stapled to it. What? You don't have those lines? Really? Holy cow, yours was given with no lines. Interesting. Okay, we'll go ahead and sketch those lines real fast. There you go. Interesting. I was wondering why everybody was looking at me weird. I mean, other than the normal reason. Okay. All right. So we don't know exactly what this intercept is. Looks like 1, 2, 3, 4, 5. Looks like it's between 5 and 6. We know that L goes through the point -1, 4. You'll go ahead and do the best you can to go ahead and recreate those. Okay. We'll run with our information. That is this one right here. That one. Yes, ma'am. It's between 5 and 6. It looks like it's almost halfway. In fact, I haven't even done this in a long time. It might turn out to be 5.5, but I honestly don't remember. We'll see how. But I know it's got to be a decimal between 5 and 6. While the other one, this one that actually gives me the equation, looks like it is crossing at -4. And 8 divided by -2, that would match up. Okay. In fact, the slope of that should be 3/2. If I go ahead and apply the opposite of A over B, so I should be able to, from this point, go up 3 and over 2. Okay, yeah, so we got that. So, okay. 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 So we'll get to it and we'll see if you're correct. No. Oh yeah, we're gonna work it out. Okay. Everybody about ready? Okay. All right. So now that we have our lines, or we're getting close to having those lines, where should we start? with L or M? Okay, L. I'd say L is a good choice. Now, is there anything we know about L besides the fact that it does go through the point -1, 4?
It's parallel to.
Okay, those notation we talked about just a second ago, we know it's parallel to this other line. And I had already provided the slope using the opposite of A over B. Okay, so if I want the equation of the line, I would probably go with what form first? We have a point and a slope. So I'm thinking point slope. Now, on the previous problem, we went ahead and went with point slope, but we do want y equals mx plus b. We could just substitute everything we have into there and solve for b. Would you like to do this one differently or just run with point slope again? Gabby, what do you think? Just go with point slope? Okay. So we're going for line L here. So y minus y1 is equal to m times x minus x1. So somebody use that point and that slope and plug in for me. What would my equation in point slope form be? So y minus 4. M, and what's m? 3/2. Okay, they're parallel, so we know they have the same slope. Times x plus 1. Okay, so y minus 4 equals, let's start to distribute, so that would be 3/2 x plus 3/2. And then y is equal to 3/2 x. So what I need to do is take 3/2 and add 4, so that would be what? 11/2. So it is right there in the center. So plus 11/2. That's going to be the equation in slope-intercept form of line L. Okay. Now, does anybody want me to show the addition of those fractions? We're good on that, right? Okay. Now, how does this help me with M? There you go. Because we know they're perpendicular, so if this line L had a slope of 3/2, well, M has to have a slope here of -2/3. And we already know what? They have the same y-intercept. That's their point of intersection. Okay, so this one, we don't have to do any manipulation. We just plug right in. Creamy? What would it be? For line M, y equals what? What's my mx plus b? Okay, well, let's take it one at a time. Do we know the slope of M? What is it? Oh, now, that's the slope for L and this other line. But remember, for perpendicular lines, we do two things. We take the opposite, and then what's our math word for flipping it? Did you hear what Alejandra said?
Reciprocate.
Reciprocal.
Cool.
There we go. Reciprocal. So that's how we got this guy right here. Because we took the 3/2, we flipped it, and we changed the sign. Okay. So we have -2/3 x. And then what's the y-intercept of line M? It's the same as the y-intercept for line L. So here's the equation for line L. What is our y-intercept? It is 11/2. So I'm going to say plus 11/2. Okay, questions? Eli, is that what you got? You were talking about the 5.5? Okay, nice. Anybody have any issues? Any problems? Bless you. Okay. All right. Well, what I'm going to go ahead and do now, let's go right on with quadratics. So I'll probably go ahead and stop, about 5 or 6 minutes before the bell. I want to go ahead and pass out your homework assignment. We don't have anything for quadratics. I just thought it was a good idea to go ahead and revisit this because a few people did seem to have some issues with quadratics when we did that system packet. Okay, so our objective is to analyze the characteristic of graphs of quadratic functions and then go ahead and graph them. So quadratic functions are nonlinear and can be written in the form y equals ax squared plus bx plus c, where a cannot equal 0. Well, why do we have that restriction? What happens if a is 0? Then it actually is what? Yeah, then it's just a line. Bx plus c, it's different variables, but it's still mx plus b. Okay, so that's why we have that restriction, a cannot equal 0. This form is called the standard form. The shape of the graph of a quadratic is a parabola. Okay, it's that U-shaped graph. They're symmetric about a central line that we call the axis of symmetry. And typically what I'm going to do is just say AOS. The axis of symmetry intersects a parabola at only one point, which is the vertex. Okay, right here. Okay, so quadratic functions. The parent is y equals x squared. Every parabola that you ever will see will come from this parent right here. This is the original. This is the first. Okay. This is something that we've talked about before. The axis of symmetry, x equals the opposite of b divided by 2a. That's going to give you that vertical line, but we use that for something else. What did we use that for? To help me find what? What's that, Samir? Yes, but what contains the maximum or the minimum? The vertex. That's what I was fishing for. Okay, you're absolutely right. So the vertex, okay, if it's not in vertex form, and while we're doing this, is anybody interested in my reminding you how to complete the square and put it in vertex form? Or do you think you're good enough just going with standard? Does anybody remember completing the square? For you folks? Okay. Well, if you would like me to do that, I will absolutely make the time. Okay, because I think this is all just good practice. So the vertex, the x value is always the opposite of b over 2a. But then what do I do with that, as Samir said, to find the maximum or the minimum? What would I do with that x value to find the y value? Yeah. What kind of notation did we call that? The function notation. Yeah, you just plug it right back into the equation. So then f of the opposite of b over 2a. Okay. That's what we were going to use to find our vertex. Now, when a is greater than 0, that means positive. It's going to open up, and it's going to have a minimum, okay, because there's going to be no point lower than that one, the element of the range. When a is less than 0, that means negative. It's going to open downward, and therefore you're going to have a maximum. Kind of think of it like the peak of a mountain or the very bottom of a valley. Okay. The maximum or minimum, I don't really agree with this. The maximum or minimum is in the vertex. Okay, the point itself tells you what the max or min is, but more importantly, where it's located. So, I don't know. That one's kind of off on me. Okay, let's try this. Use a table of values to graph y equals x squared minus 2x minus 1. State the domain and range. Okay, well, we got a table already set up. Looks like between -2 and 4. So let's just plug in like Spencer said. I'm going to go ahead and start with f of -2. So everywhere I have an x, what am I going to do? Yeah, I'm just going to replace it, and then I'm going to simplify. So x squared would be -2 squared minus 2x, so -2 times -2, and then minus 1. So what happens when you square a negative? Okay, so that's 4, then what? Minus? Plus, because the two negatives are going to give me a positive. And then, so basically 4 plus 4 minus 1. 7. Okay. Now let's go ahead and do one more of those. F of -1. So x squared would become -1 squared minus 2x, minus 2 times -1, minus 1. Okay, so it looks like I'm going to have -1 squared, 1, what? Plus 2, minus that 1. So it just gives me 2. There you go. Now, minimum, how many points do you need to create the parabola? You need minimum 3. 2 points to make a line, but minimum 3 to go ahead and get the parabola. Typically, what I like to do, here I'm just going with the table, but I like to go ahead and find the vertex, and the y-intercept, because I know it's symmetrical, I can just reflect that y-intercept over. You got your 3 points, you got your sketch of the graph. Now, you could continue to do this the rest of the way, but one of the things that I really want to make sure that you're comfortable with is the calculator. Okay. So there are, of course, different shortcuts to these. Okay, wait for this to pull up. Okay, so we're going to go ahead and graph. Let's see, what was it? X squared minus 2x? Is that right? Or am I wrong? So x squared minus 2x and then minus 1? Okay. So we're going to go ahead and see, a picture of the graph that we should be getting. But what I want to go ahead and show you here, if you do need to fill in a table, and this is for any graph, you could just hit Control T, T for table. It'll split the screen, and there's everything we need right there. Okay. And let's see, are we correct so far? We plugged in -2, got 7. We plugged in -1, we got 2. All right. And then we wanted to go all the way through 4. Okay. So you guys go ahead and tell me what these other values were. I think the next one was -1. Is that right? Then what was it? -2, -1. It was 2 and 7. And actually, if you really start to look at the different models we have, whether it's linear, quadratic, exponentials, you're going to start to see patterns in the values. Like without even seeing the graph, just given the table of values, would we be able to determine without plotting that it is a parabola? Like what do you notice? Yeah, you notice it's symmetrical, and every parabola is going to be symmetrical. Okay, because once we hit this guy right here, those y values are repeating on either side. Okay, so let's see. We have 1, -2. I'm just going to go ahead and plot these real fast. So we got 2, -1. Then we got 3, 2. And then we got 4, 7. Okay. So that one right there, the 1, -2, has to be my vertex. And this is why I like dealing with parabolas. You don't have to have a whole lot of points. In fact, however many you create in a table, when you graph it, you actually have double the number of points because you can reflect those. I know this point right here would have to reflect and be right there. See a point, and do you remember what we call the point after you reflect it from geometry? Starts with an I. Not the inverse. You see it when you look in a mirror. Image. A point and its image. Okay. Always have to be equal distance from the line of symmetry. So this one has to be 2 away. This one has to be 3 away. And there we go. There's my parabola. Okay. Good. So let's see here. Who have I not talked to today? Camille. What would the domain be? All reals, yeah. Okay. Now, if I wanted to write that in interval notation, what would I put? There we go. Because no matter what direction a parabola opens, he's going to continually widen, okay, as he grows. He's going to become infinitely wide. So yeah, every x will have a place here. Range. Hillary, help me out with that. Uh-huh. So -2 to infinity. So how do I write that? And there we go. Perfect. Perfect, perfect. Now we identify this right here. Why don't we go ahead and just take a look at that opposite of A over B, because I just want to show you that as well. Okay. X equals the opposite of B over 2A. All right. So here, remember, you have A, B, and C. The only thing is you got to have everything on the same side of the equation. Okay. So right now, with it equal to y, technically it's a function. If it's equal to 0, then it's the equation. But what's the opposite of b? 2. Yeah, because the opposite of a -2, that's 2, over 2 times a. Well, that coefficient is 1. So the vertex has to be located at 1 something, right? And again, when we plugged in 1, we got the -2. So that works out very, very nicely. Okay. Did anybody want me to show you vertex form? Does anybody remember the general form for vertex form? Does this look at all familiar? Where your vertex is going to be located at HK. Does that look familiar? Yeah. Okay. All right, well, if anybody at any point decides you want me to show you that, please just let me know. Okay. All right. Well, let's see what else we got here. A lot of information about quadratics. Figures that passes through, that passes symmetry are those in which each half of the figure matches exactly. And I'm not going to go ahead and read this word for word. It's going to get boring. It's going to get monotonous. And I know when you guys think about this class, that is not the words that come to mind. I heard some giggling, but I didn't hear anything, so my pride is hurt. It's still really quiet.
It's not boring.
Thank you, John. Thank you. I absolutely was not fishing for that compliment, but I'm glad he said it. Okay, so you got these steps here, identifying parts of the parabola, all that good stuff. Let's just get right to it. Example 2. Find the vertex, the equation of the axis of symmetry, the AOS, and the y-intercept of each function. Okay, so let's start with the vertex here. We have our A, B, and C. What was that little expression to help me find x? Negative b over 2a. Okay, so what happens if I take the opposite of b? What is b? Okay, so the opposite of -8 is 8 divided by 2a. So 2 times -2. -4, and what is 8 over -4? -2. So right there, I know half my vertex. Okay. Is this one going to have a maximum or a minimum? How do I know? A is negative, so the graph, this guy would be opening down, so I know that this maximum occurs when x equals -2. Okay, well, how do I find what that is? Plug it in. That's exactly right. I'm going to take this right here, and everywhere I have an x, I'm just going to sub in. So let's see here. F of -2, we're using function notation. So -2x squared, -2 times -2 squared, then minus 8x, minus 8 times -2, and then minus 2. Okay, so -2 times -2 squared, what would that give me? -8, then -8 times -2, plus 16, and then we have the minus 2. Okay, so I'd be looking at what? I'd be looking at 6. Well, because -8 plus 16 will give me the 8 and then the minus 2. But okay? All right. So there we go. Now, the axis of symmetry is the line that goes straight through the middle of it, but you'll notice for the AOS, we use the exact same expression that we do to find that vertex. But here's the thing, it's an equation, so you always have to write it as an equation. Is a vertical line x equals or y equals? X equals, there we go. So in this case, it would be x equals -2. Remember, that's the only point of intersection between the AOS and the parabola. Okay. Now the y-intercept, we don't have to do anything fancy, because what value always gave me the y-intercept? C is always the y-intercept. Now again, that's a coordinate, so like here we don't want to put -2. We actually want to write the ordered pair because it's a location. Okay. All right. Is this helping that we're revisiting quadratics, or do you feel that what we did the first time around was sufficient? What do you think, Evan? It feels good to revisit? Because I'm changing this every year I do it, so I want to make sure you're going to benefit from this. You don't think that we're not just slowing down. I'd rather get to trig, but I want to make sure that everybody's okay. No, everybody's saying, well, wait just a second, Mr. West. Secant's a trig function. Unfortunately, we won't talk about it in here, but okay. All right, so I'll tell you what. I've got 201, and we were able to start the next lesson. I don't think we have a whole lot left. We'll probably be able to finish this by tomorrow. So let's stop there. Okay. I also do want to go ahead and